In the vast emptiness of interstellar space, 12 billion miles from Earth, a faint signal from Voyager 2 has pierced the silence, carrying with it a mystery that challenges the very foundations of our understanding of the universe. Launched in 1977, Voyager 2 has been humanity's faithful explorer, venturing beyond the solar system to probe the unknown. But in a recent transmission, the aging spacecraft sent back something extraordinary, not routine data, but a signal so strange, so inexplicable, that scientists have dubbed it an impossible encounter. What did Voyager 2 find in the depths of interstellar space? Was it a cosmic anomaly, a phenomenon that defies the laws of physics, or something far more unsettling? Perhaps evidence of an intelligence we are not yet prepared to comprehend? This article delves into the story of Voyager 2, its historic journey, the baffling data it has returned, and the chilling possibilities that now confront humanity. The story of Voyager 2 begins not with advanced technology or sprawling bureaucracies, but with a single, brilliant insight from a young doctoral student named Gary Flandreau in 1965. While working at NASA's Jet Propulsion Laboratory, JPL, Flandreau noticed a rare celestial alignment. Jupiter, Saturn, Uranus, and Neptune would soon position themselves in such a way that a spacecraft could use their gravitational fields to slingshot from one planet to the next. This alignment, occurring only once every 176 years, presented a unique opportunity to explore the outer planets in a fraction of the time it would otherwise take. A journey that might have spanned 30 years could be completed in just 12. Seizing this once-in-a-lifetime chance, NASA launched the Voyager program, consisting of two spacecraft, Voyager 1 and Voyager 2. Launched on August 20, 1977, Voyager 2 was designed as the more ambitious of the two, tasked with an extended mission to explore not only Jupiter and Saturn but also the distant ice giants, Uranus and Neptune. Equipped with 1970s-era technology, including a modest computer with just 69 kilobytes of memory and a power supply fueled by decaying plutonium, Voyager 2 was a marvel of engineering, built to withstand the harsh conditions of space and transmit data across billions of miles. Voyager 2's journey through the solar system was nothing short of revolutionary. It provided humanity's first close-up views of the outer planets, revealing worlds far more dynamic and complex than scientists had imagined. At Jupiter in 1979, Voyager 2 captured images of the Great Red Spot, a storm larger than Earth, and discovered volcanic activity on the moon Io, spewing sulfur and oxygen into space. At Saturn, in 1981, it revealed intricate ring systems and new moons, painting a picture of a planet surrounded by a delicate cosmic dance. But Voyager 2's most groundbreaking discoveries came at Uranus and Neptune. In 1986, it became the first and only spacecraft to visit Uranus, revealing a pale blue world with faint rings and a collection of previously unknown moons. The planet's atmosphere, composed primarily of hydrogen and helium, was found to be the coldest in the solar system, with temperatures plunging to -224 degrees Celsius -371 degrees Fahrenheit. 3 years later, in 1989, Voyager 2 reached Neptune, capturing images of its deep blue hue, caused by methane-absorbing red light. It discovered the Great Dark Spot, a massive storm, and winds reaching speeds of over 1,000 miles per hour, the fastest ever recorded in the solar system. Triton, Neptune's largest moon, stunned scientists with its nitrogen-spewing geysers, hinting at geological activity on a world thought to be frozen and inert. After its flyby of Neptune, Voyager 2's primary mission was complete. Its cameras were powered down to conserve energy, and the spacecraft was expected to fade into obscurity, drifting silently through the void. But NASA had other plans. Voyager 2, along with its twin, was redirected toward interstellar space, carrying with it a golden record, a gold-plated copper disc etched with sounds, images, and greetings from Earth, intended as a message to any extraterrestrial civilization that might find it. In November 2018, Voyager 2 achieved a milestone no other spacecraft with functioning instruments had accomplished. It crossed the heliopause, the boundary where the solar wind, a stream of charged particles from the sun, gives way to the interstellar medium, the sparse matter and radiation between stars. At 11.7 billion miles from Earth, Voyager 2 officially entered interstellar space. Joining Voyager 1, which had crossed the heliopause 6 years earlier in 2012. The data Voyager 2 sent back from this frontier was astonishing. While Voyager 1 had encountered turbulent magnetic fields and chaotic plasma waves at the heliopause, Voyager 2's crossing was unexpectedly smooth. The magnetic field beyond the heliopause was stable, almost serene, defying decades of theoretical models. Scientists had predicted that the interstellar magnetic field would fluctuate in sync with the Sun's 11-year cycle, but Voyager 2's instruments detected no such variability. It was as if the spacecraft had entered a region of space untouched by the Sun's influence, a cosmic calm that raised more questions than it answered. In the years following its heliopause crossing, Voyager 2 continued to transmit data, monitoring cosmic rays, magnetic fields, and plasma waves. But in early 2025, something extraordinary happened. The Deep Space Network, DSN, NASA's global array of radio antennas designed to communicate with distant spacecraft, received a signal from Voyager 2 that was unlike anything it had sent before. The signal was faint, fragmented, and corrupted, not by random noise, but in a structured pattern that suggested deliberate interference. For a brief moment, communication with the spacecraft was lost entirely. Then, inexplicably, Voyager 2 reoriented its high-gain antenna and re-established contact on its own, a maneuver it was not programmed to perform. When the signal resumed, it carried a burst of data that defied explanation. The spacecraft's instruments reported magnetic spikes with no apparent solar or cosmic source, radiation patterns unlike those observed near stars or nebulae, and a subtle but measurable shift in the spacecraft's trajectory. Most disturbingly, Voyager 2's plasma wave instrument detected a low-frequency hum, a constant vibration that appeared to originate not from the galactic core or background radiation, but from something local, near the spacecraft. This was no ordinary cosmic phenomenon. It was, in the words of one JPL engineer, impossible. NASA's public response was measured, attributing the anomaly to cosmic interference or an onboard glitch. But behind closed doors, the event was referred to as the encounter. The data suggested that Voyager 2 had not simply drifted through a random patch of space but had interacted with something that had altered its behavior and perhaps its course. To understand the significance of this encounter, we must revisit one of the most iconic elements of the Voyager mission, the Golden Record. Conceived by astronomer Carl Sagan and his team, the record is a time capsule of humanity, containing 115 images, greetings in 55 languages, natural sounds like wind and thunder, and a selection of music ranging from Mozart to Chuck Berry. It also includes a map pinpointing Earth's location in the galaxy, using the positions of 14 pulsars as cosmic landmarks. The record was a gesture of hope, a message to any intelligent life that might one day find it. But what if that message has already been received? The structured nature of the corrupted signal, the unexplained reorientation of Voyager 2's antenna, and the mysterious hum detected nearby have led some to speculate that the spacecraft may have encountered something aware of its presence. Could the Golden Record, intended as a beacon of humanity's existence, have attracted the attention of an intelligence we cannot yet comprehend? The possibility, however remote, is chilling. Voyager may have crossed paths with something that noticed it and responded. The mystery deepened in the weeks following the encounter. Mission Control noticed that Voyager 2's attitude, the orientation of its instruments and antenna, had changed subtly but significantly. This was no random drift or mechanical wobble. The spacecraft had redirected itself, as if adjusting to observe something specific. Voyager 2's autonomous systems are designed to correct for signal loss or orientation errors, but no such errors were detected. The spacecraft's diagnostics showed no faults, no impacts from cosmic dust, and no interference from external forces. Yet it had chosen to look elsewhere. This unexplained adjustment sent ripples of unease through the Voyager team. If Voyager 2 was responding to something in its environment, what was it? Was it avoiding an obstacle, tracking a phenomenon, or, most unsettlingly, following a directive from an external source? The spacecraft's limited computing power, equivalent to a modern pocket calculator, makes the idea of autonomous decision-making beyond its programming almost unthinkable. Yet the data was clear: Voyager 2 was behaving in ways it was never designed to. As if the reorientation weren't disturbing enough, Something even more alarming occurred in the days that followed. Voyager 2's scientific instruments, those tasked with measuring cosmic rays, magnetic fields, and plasma waves, fell silent. The spacecraft was still operational, responding to pings from the DSN and sending telemetry data on its power levels, temperatures, and system status. But the flow of scientific data had stopped. It was as if Voyager 2 had deliberately muted itself. NASA initially kept this development under wraps, with internal teams scrambling to diagnose the issue. Was it a fault in the aging hardware? A power-saving mechanism triggered by low-energy reserves? Or something more deliberate? A leaked internal report, later circulated among astrophysics students, mentioned a potential autonomous instrument suppression protocol, a term that sent shockwaves through the scientific community because no such protocol exists in Voyager 2's programming. The silence of the instruments suggested that the spacecraft had encountered something it either could not process or was prevented from transmitting. The scientific community has been abuzz with theories attempting to explain Voyager 2's behavior. Some are grounded in known physics, while others venture into the realm of speculation. One leading theory posits that Voyager may have passed through a region of dark plasma, an exotic state of matter theorized to exist in the interstellar medium. Dark plasma, rich in magnetic anomalies and gravitational inconsistencies, could potentially interfere with a spacecraft's sensors and systems. However, even proponents of this theory admit that it does not fully explain the structured nature of the corrupted signal or the spacecraft's autonomous reorientation. A more controversial hypothesis comes from a small group of SETI, Search for Extraterrestrial Intelligence, researchers. They point to the structured pattern in the corrupted signal, which bears a striking resemblance to compressed data encoding used in early Earth-based binary systems. While the signal's contents remain undecipherable, its non-random structure suggests it could be engineered, a message or interference from an unknown source. The most radical theory proposes that Voyager 2 encountered a form of passive alien technology. Not a spacecraft or a direct signal, but a relic or surveillance node left behind in interstellar space. Such a device could be designed to detect and interact with passing objects, perhaps scanning or redirecting them. If true, Voyager 2's altered trajectory and silenced instruments could be the result of an interaction with a technology far beyond our own. The possibility that Voyager 2 has encountered an intelligent presence raises profound questions. The spacecraft, built with 1970s technology and powered by a dwindling plutonium battery, was never designed to interact with advanced systems. If it has indeed crossed paths with an alien intelligence, what does that mean for humanity? The Golden Record, with its detailed map to Earth, was intended as a gesture of goodwill, but it also serves as a cosmic homing beacon. If something has noticed Voyager 2, it may now know exactly where to find us. Some astronomers speculate that Voyager 2's subtle shift in orientation, pointing slightly back toward Earth, could be a navigational correction. Others, however, see it as something more ominous, a signal that the spacecraft is returning, perhaps under the influence of an external force. The idea that Voyager 2 has crossed a threshold into a region of space that is not empty but occupied challenges our assumptions about the universe and our place within it. The Voyager missions were always about more than science. They were a testament to human curiosity, ambition, and the desire to reach beyond our world. Voyager 2, in particular, has been a trailblazer, revealing the wonders of the outer planets and pushing the boundaries of human exploration. But its latest chapter, marked by the impossible encounter, suggests that the journey is far from over. If Voyager 2 has indeed encountered something beyond our understanding, it may have opened a door to a new era of discovery, or a new set of risks. The spacecraft's silence, its altered course, and the mysterious hum detected in the interstellar void all point to a reality we are only beginning to grasp. Was it a natural phenomenon, a cosmic anomaly, or a deliberate interaction? The answers remain out of reach, drifting in the darkness where Voyager 2 continues its lonely voyage.